All right, number 4, we've got this equation cosine negative 1, 8x to the 4th plus 14x squared minus 16 is equal to pi. All right, now in this one, the thing that's with our cosine negative 1, it's got variables in it. We don't know what that is. And we do know what pi is. And where normally what we've been doing is we've been finding an angle when we've been given a side. Well, now what we can do is we can reverse the same process. If I take the pi and put it in the parentheses, well, then it's going to change from cosine negative 1 to just plain cosine. So here we go. This is the beginning. This is what it starts. It looks like right now. And what I want to do is I want to switch places and put the pi here and the other polynomial on the other side. In order to do that, I just got to switch this negative 1 to a 1. And see, now I'm finding the cosine of pi. Well, the cosine of pi is negative 1. And see, now I've got this polynomial equaling negative 1. Well, I can go ahead and make it equal to 0. I recognize that it's somewhat of a quadratic-ish kind of a thing. What I can do is substitute in here, and I can say that, say, h is equal to x squared, and then rewrite this as a quadratic, which would be 8h squared plus 14h minus 15, and then treat it like a quadratic. And in this case, I'm just going to go ahead and use the quadratic formula, probably factors, but I'm going to try doing this. So 14 squared minus 4 times 8 times negative 5, all divided by 16. And what you're going to find out is it's negative 14 plus or minus 26 over 16. So our h is going to equal 3/4. And it's also going to equal negative 5/2. Now keep in mind, we just found h. We've got to actually find x. So h is equal to x squared, so I replace the h with an x squared. And see, now all I got to do is square root both sides. Well, keep in mind, when you square root a I can't never get a negative. They don't know about i's, so that's not going to be a possible solution. And so when I square root this, it's going to be plus or minus the square root of 3 over 4, or the square root of 3 over 2. All right, hope that helped. Now let's take a look at number 5. In number 5, it says solve this equation, sine 2x equal 5. And we're going with this range of from 0 to 180. Now keep in mind, if you've got an equation and just have signs, just sines and cosines, if you divide everything by cosine, it's going to turn into tangent. So let's try doing that. Now in this case, it's got a 2x. We have to divide by cosine 2x. And when we do that, we're going to get tangent 2x is equal to 5. Now that's good. Now keep in mind, when we have this, we got to take it out, and we'll come back to it later. And we also have to expand our range. It's going to be twice as big. So 2 times 0 is 0, and 2 times 180 is 360. Because what's happened is the angles we find, we're going to have to divide them by 2. So we want them to be twice as big. Anyway, now we can go ahead and do the inverse of this. Tan negative 1 of 5 is equal to my angle. And I'm going to find out that that's going to be 78.69. And if I add 180 degrees, I'm going to find out that I get 258.69. I double check, and those are the only two angles I can fit within the range. So now what I do is I go back and I recall, okay, I've just found theta, but what I need to find is x. So I replace my 2x with the theta, and now it's going to be 2x equals 78.69, and I just divide by 2 for both of these angles, giving me the answers of 39.345 and 129.34. Okay, we checked the range, and we're in good shape. Hope that helped. Thanks for watching.